So we did inheritance last time, and we looked at the basics of inheritance in chapter 15. Today we're going to continue. We're going to talk about a new topic which is called polymorphism. Before we introduce polymorphism, there's a topic which is called the slicing problem that we're going to introduce, and then we're going to introduce virtual functions, and through virtual functions we're going to understand polymorphism. So there are three things to be done. This is best explained through an example, so we're going to look at a full example, and then we're going to look at the slides and fill in the gaps and answer any questions that you might have. But what we have in front of us now is very simple. Three classes. We have a class, superclass, or a base class called person, and we have two derived classes. One of them is called student and the other one is called staff. As you can see, those are quite basic. So we have a default constructor with the name being person, one protected member. We agreed that in inheritance we use protected such that they can be directly accessed by the child classes or the derived classes. So there's student, and it also inherits from person. It adds one extra attribute, which is the major. For the time being, forget about virtual. We'll talk about that as we move on. And then we also have a person, a staff that extends person, and it has another member which is called rank. So in the superclass there is name, and in the two subclasses, one of them it extends and it adds the major, and the other one it extends and it adds the rank. Okay? But for the time being, forget about the virtual classes, the virtual functions, and we'll come back to that in a minute. Okay. So now in the main program, what we have is we have an object of type person and an object of type student. Okay? Very straightforward. Up to this point, the constructor of person will be called and the constructor of student will be called as well. Okay, now this is new to us. You can do this in C++ without casting. You can assign the student to the person. Does it make sense to you? What extra information do we have in the student that is absent from the person? The major, right? But the student, does it have a name? It does. It's inherited from the person. So the name will be assigned to the name, but the major will be lost. Because we cannot assign the major to the major because the person does not have an attribute called major. So although C++ will allow you to do this, but some of the information will be lost. So now this person will have a name, but the person will not have a major because that attribute does not exist in the first place. Now this is very obvious, or the name itself is intuitive. The name of this problem is called the slicing problem, because if you wish, you can think of it as the major of the student has been sliced out. Okay? And only the name was copied to the person and the major was sliced out. So this is called the slicing problem. In C++, it will allow you to assign a child class to the base class without casting. Okay? Bye. Now, if we try to print out the name of the person in the constructor of students, what's the default name? There's no default name, right? In the constructor of the student, it will call the constructor of the person. In the constructor of the person, it will assign the name person. So at this point, if we print out the name from person, what will it print out? Person with a capital P. But if we try to call now the function which is called getExtra, let's have a function called getExtra for person. If you call the function person.getExtra at this point. Now in the student, when we print out the extra information, it will print out the major. It will retain the major. For the staff, when we call the function getExtra information, it will retain the rank. So we're talking about the extra information that we have in each child class. But for the person over here, when we call the function getExtra, there's no extra information to be returned, right? So just for illustration purposes, I wrote that this is a person. There is no extra information to be printed out. I just wanted to illustrate that the major of the student was just sliced out and there is nothing to be printed out at this point. Okay, so up to this point I think it's quite straightforward. We can run it and stop at this point if you wish. It might not compile because we're calling other functions somewhere else. So we did compile, start without debugging. So the name was printed out after assigning the student to the person. The name was printed out, which is person. We called the function get extra information. The extra information was not copied, it was sliced out, and hence we printed out that this is a person. There is no extra information, right? Okay. So now we understand what the slicing problem is. Again, just to summarize, it is allowed to assign a derived class to a base class, but when you do that, the extra information which is stored inside the derived class will be lost inside the base class. So now the base class only contains the name but does not contain the major. So this is called the slicing problem. Okay, so now, yes?
What about just get extra info? Was it print out to get extra function from the person class or the student class?
Okay, so now the question is, when we call this function, which is get extra information, it's defined in person and it's also defined in student. So now the question is, which version of those two will be called? Obviously, the calling object is of type person, so which one will be called? The one from person, right? But now we will see that there might be a different arrangement. And I know where your concern is coming from, because you're saying that we're assigning the child to the base, okay? But, so now, the solution for this is something called virtual functions. So now what we're going to do is the following. We're going to create this function, which is called the get extra information function, and we're going to declare it as virtual. So at this point it will not make a difference. We're still okay. So now I'm going to go to person and make this function virtual, and I'll explain that in a minute. Okay. Just write virtual. The first word is going to be the first word. The word virtual, the keyword virtual, it goes into the declaration, not the definition. Okay. So if this function was defined somewhere else in a different file, for instance, you don't start with virtual. Virtual is only needed at the declaration, not in the definition. If you write it at the definition, you will have a syntax error. It will let you know that you did something wrong. So what difference does it make? Now, we're trying to solve the slicing problem, and this is directly related to the question that Amar asked. Now, when we have the function as virtual, the point is, when we assign a student to person and we call the function from person, when we call the function get extra information, we want this version to be called of the child class, but not this version. And this is the idea of virtual functions. For virtual functions to work, you have to have pointers. And let me explain what that is to you. Now, this is the second step over here. Now, let's declare at this point, what do we have? What's the type of person PTR? Did you say string? So we read declarations from right to left as we agree. So this is a pointer to a person, right? Okay. Now, we already have an object of type student, right? So at this line of code, what are we doing? We're taking the address of the object student and we're storing it inside person, right? Again, in C++, this is allowed. Just like you can assign a child class to the base class, you can also assign the address of the child class to the address of the base class. So you can either do it with pointers or without pointers. So in the first step, this is what we did. We did that without pointers, right? In C++, it's also allowed to do it with pointers. But is there a different way of doing this? Now, notice that those two are the same. So if I have an object which is called student pointer, PTR, let's make it a pointer. So in that case, what do I write? I can write something like PTR, person PTR is equal to student PTR, right? And at this point, I don't need to take the address, right? Because student PTR is already an address. But in this case, I took the address because the type of S is a student. It's not an address of a student. You know this, of course, but just to refresh your memory. And I need your attention. There is one thing at this point. When we declare S as a student, the constructor is called by default. The default constructor is called automatically. When you declare an object of type address of an object, the constructor is not called. So at this point, constructor is not called. The constructor is called only when you declare an object of type student, but not an address. So if you declare an address, the constructor is not called. How do we call the constructor? Now, if we have integer star I, do we have an integer? No, we don't. We have an address of an integer. How can we create an integer? Later on, yes, in new. We say that I is equal to new int, and we're done, right? This is not an array. It will create one integer, and it will take its address. And it's the same thing with student. Up to this point, we don't have a student. How can we create a student? We can say that student ptr is equal to new student. It's exactly the same example that we did with integers. Now we have created a new student, a new object of type student, and we took the address and we stored the address inside student ptr. So now at this point we can write that the address of the student is stored inside the address of the person. So now both student, both S pointer and P pointer, both of them, they have the address of the same object. And what's the type of the object? Student, right? So now we have created a student inside the heap, and we have ptr, which is person ptr, and we have student ptr. Both of them, they hold the address of the same object. Both of them are referring to the same object inside the memory. Okay? Now, whether we wrote it this way or we wrote it that way, both of them are similar. Both of them, at the end, they are referring to the same object. So let's write it using pointers all the way. Okay. Now, we created one student over here, right? Does it make a difference, just to let you know, that in C++ you can also write it this way, and both of them are fine. ptr, student ptr is equal to new student as a function call. Both of them are acceptable. Okay. Which one are you more comfortable with? This one gives you the feeling that you're calling the constructor, right? But this one is very similar to saying a new integer. Both of them are fine, just to let you know. Maybe this one is a bit, it has an advantage, just to let you know that, that you can also call non-default constructors. So if you have a student that has a default constructor and a non-default constructor, and you want to construct the student using the non-default constructor, you can do this. Okay? So you're not restricted to the default constructor when you use the new keyword. So maybe this is more elaborate. If you wish, we can just write it this way with the parentheses, just to let you know that you are not restricted to the default constructor. You can either call the default or non-default constructors. Do we have non-default constructors in this example? No, we don't. Okay, so we're stuck with the default constructor in this case. Okay. Yes?
Why didn't we say PTR equal to no?
We can do that, of course. Now this is your question. Your question is, can we say new person? Yes, we can, but we're not discussing this now. What we're discussing is, we want both the parent and the child to refer to the same object, which is of type child. Because we started with the following discussion. Parent is equal to student. Right? This is the problem that we are addressing. The problem that we are addressing at this point, again, this is a repetition now, that C++ will allow you to say parent is equal to student. So if you say parent is equal to student, student is a superset of parent. Student has more information than parent. When you assign student to parent, some information is lost. Which information is lost in this case? The major. So this is called the slicing problem. So now we're addressing the slicing problem. Okay, we're not addressing anything else at this point.
So the pointer approach will solve the slicing problem?
We're getting there one step at a time, Ali. So now what we have is we created pointers. Now the ingredients to solve the slicing problem are two things: the virtual keywords and the pointers. Virtual on its own, it's not enough. And the pointers on its own, it's not enough. We have to have virtual and pointers. Okay, now through the pointer, I want to call a function. So what's the name of the function? Get name, right? There was a function called get name. So ptr dot get name. I want to print it out. C out. Now you can see immediately at this point that there's a syntax error, right? Because ptr is not the name of an object. What's ptr? It's an address of an object. You cannot, there's no calling object on the left hand side. This is not a calling object, this is an address. This is not allowed. So what we need to do, we need to dereference the person ptr first. And of course you do remember dereferencing. Now it's okay, right? So you need to dereference first. Now C++, it has a special symbol for the dereferencing of objects that you can use instead of using the star and the brackets. What you can do in C++, and it's very common when you have pointers to objects, is to use this notation, the arrow. Okay, so when you see an arrow, immediately you will know that what you have on the left hand side, it's not an object, but it's a pointer to an object. Okay, which one are you more comfortable with? It's up to you really. If you want to dereference or you want to use the arrow notation, it's up to you. Yes.
The arrow notation dereferences
yes, the arrow notation will dereference PTR. So the arrow notation is just simply a shortcut for this. So internally C++ will replace it with this. Okay. Now here's the surprise. At this point, whether you're using the arrow notation or you're using dereferencing, we're going to call the function which is get extra information. Person has a function which is called get extra information. Person has a function which is called get extra information. Student has a function which is also called get extra information. But now we have the two ingredients. We declared this function as virtual and we're using pointers. So now I'm going to trace this program, and at this point we're going to try to see which get extra information is being called, the one from person or the one from student. Of course you know the answer by now. It has to be from the student. So let's try that. Somewhere else in the code I also have, so let me comment this out. Okay, so let's start debugging. This is where we are. If you move the mouse at this pointer, you will see that we'll see that this is the student that it's pointing to, right? Trusting one. Virtual, this is the virtual. Okay, and at this point what we have on the left hand side over here is a pointer to a person. But since we have pointers and we have a virtual function, so now when we step inside this function call, it will send us to the student class, and what this will print out is actually the major of the student. So although it was sliced out, right? But if you use the two ingredients of virtual functions and pointers, you can access that information. So this is the solution to the slicing problem. Okay, now some extra details. So we can stop the debugger at this point. Maybe not too important for you at this point, but just to let you know that once you declare a function as virtual, it is automatically virtual in all the subclasses. So whether or not you write virtual at this point, it doesn't make a difference because C++ will deal with it as a virtual. Does it make a difference? It doesn't make a difference unless there is also another class which is inheriting from student. So let's assume that from student there are two subclasses, undergraduate and graduate. Okay, so now you have three levels of inheritance. So you have class A and then class B and then class C. Now it makes sense. So if you have a function as virtual, at this point it is automatically virtual in B and it's automatically virtual in C. Okay, so again, whether or not you write it in the staff as well, virtual, it's automatically virtual as well. Okay. So, again, just to summarize now, C++ will allow you to assign a child class to a base class. When you do that, you lose the extra information. This is called the slicing problem. Through the parent class now, which is P, or the base class, you cannot access the extra information. Okay. However, if you use pointers and you use virtual functions, then C++ will allow you to access the extra information that was sliced out. Okay, so this is called virtual functions. Okay, now let's take it one step further. So we're done with this part. Now we can comment it out. Let's move on to the fourth step now. Okay. So now we know the slicing problem, we know the virtual functions. Let's look at polymorphism. What does polymorphism mean in English? Polymorphism. Jad, you did writing 101, right?
Yes, I did writing 101.
What's polymorphism? Polymorphism, it means having more than one face. But why is having more than one face is related to what we are discussing now? Because this is a pointer to person, yet it has a different face because it's also at the same time it can be a pointer to a student. It's a person, yet it has another face because it can access the major information of the student. And let's illustrate this polymorphism further now with the following example that we have in front of us. Let's create an array of pointers. So let's simplify it. Let's have the array size as 2. And we're going to create a pointer to a student and a pointer to staff. So now those are the two subclasses that we have. In our inheritance, we have the A, B, and C. This is how it looks like. So this is our superclass, which is parent, and this is student, and this is staff. Okay? So now we have, and let's create, at this point, what do we have at this point? What did we declare? Two pointers to a person. Size is 2, right? We declare 2 pointers to a person. We did not declare 1 pointer. This is 1 pointer. This is 1 pointer to a person, right? Fine. Those are 2 pointers to a person. And those are 20 pointers to the person. In our case, we're just going to use 2 of them. Okay, so what we have an array of
person.
We have an array of person pointers, yes. So this is the array, this is how it looks like. We have address 1, and we have address 2, and the name of the array is PTR. The name of the array has the address of the first element inside the array. Okay, so now we have declared 2 pointers of type person. Now, what we are going to do is the following. Of course, this will not work at this point. If we try to compile, at this point, it will give us a compilation error, and it will say that you're using the SPTR pointer without initializing it. This is the student pointer, right? It's not initialized. We did not use the new keyword, and we did not even give it the value null. It's not initialized. At this point, it will not compile. At this point, it will fail. Okay? So what we are going to do instead, as we did in the previous step, we're going to say that this is equal to, in U, student, and we're also going to write that this is equal to new staff. Okay, so now we don't have a problem over here. This is fine because we have initialized both of them. Right. At this point, what's happening? What's being assigned to what? The address of the student is being assigned to the first array element, right? And then the address of the staff is being assigned to the second array element. Okay, so now this is pointing to an object of type student, and this is pointing to an object of type staff. Okay, now let's have this nice loop over here, and inside this loop we are looping through one element at a time. So we're looping through the first address and then the second address, right? Because I is first 0 and then I is 1. So now we're going through the first address and then the second address, and then we are dereferencing. If you wish, you can write this as a dereferencing notation, because what we have inside the array is a pointer, right? So we need to dereference the pointer first. After dereferencing the pointer, we're going to call get extra information. In the first iteration, loop iteration, what's going to be printed out? The major, right? Because the first pointer points to student, and when we print out the extra information, what's being printed out? The major. In the second loop iteration, what we are pointing to is a staff, and now the get extra information is going to be called from the staff, and what's going to be printed out? The rank. Let's convince ourselves that this is true. Just take a minute to do that. So I'm going to have a breakpoint and compile and debug. Okay, so start without debugging. Debugging. So let's look at PTR now. As you can see in PTR, we have a student and we have a, yeah? Okay, those are two addresses. But when you look at the pointer over here and you expand it, you can see the extra information. The only reason that you can see the extra information through the base class is that you have to do ingredients. What are they? Virtual and pointers. Okay, so now step into, and the first is a pointer of type student, and in the second loop iteration it's a pointer of type staff, and therefore what we have in front of us now is the extra information from the student class and then the extra information from the manager class. So what we have covered is slicing problem, virtual functions, and polymorphism.
So why do we have person printed twice?
We code the function twice. If you look at the code, we code the function twice at the beginning. It's not important. But, so now what you have in front of you in the slides is a very simple example, very similar example. In fact, it's simpler than the one that we looked at. And it's using superclass called pet and the subclass called dog. And the dog has extra information which is called the breed of the dog. Okay, and again there is pointers and there's the virtual and there's the dereferencing, but this is a simpler example than the one that we looked at again, so you can just look at it at your own time. Fine. So we have two rules. Let's look at those. If the domain type of the pointer ancestor is a base class for the domain type pointer descendant, the following assignment of pointers is allowed. So we know that in C++ now you can assign the derived class to the base class. You can also assign the address of the derived class to the address of the base class. Okay? But if you don't have virtual functions and pointers, then you'll have this slicing problem. So although the fields of the descendant are there, so in our case like we had the extra major, Virtual functions are required to access them. You cannot access the major of the student without pointers and virtual functions. And again, this is what we did. Virtual destructors, we'll come back to virtual destructors in a minute. Okay, so the slicing problem and the rest of it, I think we understood the topic. So please do look at the slides and the chapter and make sure that you go through it. Okay, now there's the one last topic in virtual functions and polymorphism, which is called the virtual destructors. By the way, just for your own information, it's very typical that after graduation, if you have a job position, job interview in programming, one typical question, it has been there since forever. The interviewer will ask you, do you know C++? And you would say yes. How many courses did you do in C++? I did 3 courses. Programming 1, programming 2, and data structures. All of those are C++. The first question you'll be asked, explain polymorphism to me. Very typical question in job interviews. Okay? Even if you're going to do an internship, maybe 1 or 2 years from now, you might also be asked about polymorphism if you want to work in programming. Many students, they might know what polymorphism is, but, you know, surprise question, they did not expect it, they did not revise and so forth. But just to let you know, in real life now, how much is polymorphism used? I think you're going to go through a data structure course and maybe you're going to see polymorphism once or maybe not. Okay, but it's a very important topic that reflects your understanding of objects, of classes, of pointers, and the rest of it. Okay, so if you understand polymorphism, it means that you have understood everything else. What does it contain? It contains object orientation, inheritance, pointers, right? So it's roughly the whole thing. Constructors, destructors. So if you understand polymorphism, you have understood everything that we have talked about. Virtual destructors. So we can have virtual functions and we can also have virtual destructors. When is a destructor called? When an object goes out of scope, right? Right. Now, if you write the code similar to this, and you use the new keyword, now we know that whenever we use the new keyword, somewhere inside the program we have to use the delete. So now we can delete the student PTR, right? We're not deleting an array, this is not an array. We can delete student PTR, because PTR is not an array, it's only one student, right? When you delete the student PTR, if there is a destructor, the destructor will be called. So I just want to illustrate that the destructor will be called if you have created the object using a new, or if the object goes out of scope if you did not use pointers. So without pointers, if the object goes out of scope, the destructor is called. If you're using pointers, if you use the delete keyword, the destructor will be called. Okay.
If we didn't have delete, if we remove the keyword delete, the destructor will never be called. For this.
If you don't delete, the destructor will never be called, even if this goes out of scope. No, because when you use a new, the object will remain there forever until you delete it, or until the program terminates. Yes.
Why are we creating an object of person that we are creating like pointers, like we are pointing two objects to separate locations? Why are we creating an object of person and then pointing it to staff and student?
So what do you want me to do? What shall I write?
I'm saying why aren't we just creating an object of person and then pointing?
Yes. Okay. What shall I write? Person.
Like before that, we should person equals to new.
Person star p ptr equals a new
Function.
a new person. Then.
And then you create an array of that, or like create an array of objects, and then point it to staff and student. Like why wouldn't we be a pointer?
Please, one step at a time. So what do you want me to do now?
Now we want to create an array of objects.
Array of pointers, so I have to have this as size. Okay. And then we're creating 2 of them, or size of them. Then what?
And now I can point directly to
How? What shall I write? P underscore PTR at index 0
equals to
equals S underscore PTR. Now what happened to this pointer over here is that you have created a person and then you trashed it. You created a person and you trashed it. PTR, and then you say, I've created a person. At this point you created a person, right? And then you're saying, no, I'm going to create a student. I changed my mind. Thank you very much. I don't want to point to you anymore. Who's pointing to this now? Got it? Okay. So now virtual destructors, if we have we can do the following. We can say that the base class like person is equal to new student, believe it or not. So we're doing two things at the same time over here. We can say that base, so this would be exactly as if we are writing person star P is equal to new student. This is also allowed. And this is the first time that we see this, right? And we can say that person is equal to new person. That we can understand. But you can do the following as well. This is the same as saying person P is equal to, let me type it over here. This would be the same as if you're saying person star PTR, and then you have student star student PTR is equal to a new student, and then you say PTR person PTR is equal to student PTR. You can do all of this in one step. You can do all of this in one step by saying that person PTR is equal to new student. Right? Okay? So this is what we have in the slide. In the slide it's saying that we have a person and this person is equal to new student, or you can do it in the explicit steps as we saw a minute ago. Now when you delete the student, when you delete the person over here, or the base class, the destructor will be called. But now the question, which destructor will be called? If you have the destructor as virtual, which destructor will be called? Now those are two examples to illustrate this. Here's the first example. In the first example, maybe the color is not a good choice. In the first example now, we're going to have a destructor, but this is not a virtual destructor. In the second example, we're going to have a virtual destructor, and let's see what's the difference between the two. Now, this is the base class, and this is the derived class. The derived class, it inherits from the base class. In the base class, we have a destructor, and just simply prints out that the base destructor has been called. In the derived class, it has a destructor, and just simply says that the derived destructor has been called. Now, at this point in main, we are creating a pointer of type base, yet the object that it's pointing to, it's not of type base, it's of type derived. Okay? So now what we have is the following. We have an object of type derived, and we have an object of type base which is pointing to it. Okay? Again, we could have wrote this in a number of steps. I'm repeating myself now. This is of type base, star B, and we have derived star D, and then D is equal to new derived, capital D, and then what's the last step? D is equal to D. Or you can just write it in one step using this approach. And when we delete the base, which destructor will be called? The destructor is not virtual, which means that at this point it's the destructor of base that will be called. There is no polymorphism. There is no more than one face, because virtual was not used. To have polymorphism, you have to have virtual functions. We don't have virtual functions over here. We don't have more than one face. It's only one face as far as the destructor is concerned. So now we're calling the destructor of base, and what will be printed out is the following statement only. The base constructor has been called. Now if you repeat this and you make the destructor virtual and you call the destructor at this point when you delete the base. Now since the destructor is virtual, what will be called is the following. The base destructor of the base class will be called first, base destructor called, and then the derived. Let's try that. It starts with the derived, that's why I was confused. So it starts with the derived destructor has been called, and then the base destructor has been called. So let me fix it on the slides. It will start with the derived, and this is the sequence. Okay. Do you remember, guys, in constructors we said that when you create an object of type derived class, the constructor of the superclass will be called automatically, and we mentioned that the direction for calling constructors is in this. Was it in this direction or in this direction? When you call constructors, does it start from the superclass or the base class? The base class or the child class? To start from the base, start from top. So constructor is this direction. Destructor is the other direction. So for the destructors, when you have virtual functions, what will happen is that the destructor of the derived class will be called first, derived class, and then the destructor of the base class will be called second. So it's in the other direction of the constructors. Now what's the difference between virtual functions and virtual destructors? The difference with the virtual destructors is that both functions will be called, both functions of the derived and the base. Whereas in the previous example, when we printed out get extra information, the get extra information of the student was called, but not the get extra information of the person. But destructors is an exception. So when you have destructors and they are virtual, then all the constructors of the superclasses are called, just like the constructors. When you have the constructors, all the constructors of the superclasses are also called, but they are different in the which one starts first. So in virtual destructors, we always start with the derived constructor. Okay, so back to the rules now. If the base destructor is not virtual, only the base destructor is involved, right? So we started with this example. If this wasn't virtual, then only the base destructor is going to be called. And this leaves the derived members not part of the base in memory. So which means that if in the derived class over here, you use the new keyword, and the destructor of the derived was not called, it means that you have used a new without delete, which is a problem. Okay, so it's important for us to call this destructor, and the only way to call it is by the use of the virtual functions. That's it. So again, so just to summarize that, if you have destructors and destructors are virtual, then the destructors of both the derived class and the base class will be called in that particular sequence. And if you have one more than two levels of inheritance, then it will also go from bottom up, as opposed to constructors. In constructors, there is no virtual constructor. There's virtual function, there's virtual destructors, but there's no virtual constructor. Okay. And the difference, again, the difference between virtual functions and virtual destructors, With virtual functions, only the virtual function of the derived class is called, like get information of the student and the major was printed out only. But if you have a virtual destructor, then both the virtual destructor of the derived class and the virtual destructor of the base class are called. Okay, that's another scenario. If the virtual functions, if the destructors are not virtual, only the base destructor is called. This is not the case for constructors. For constructors, whether or not they're virtual, constructors are not allowed to be virtuals. In constructors, it's always the case that the base class constructor is called first, followed by the constructor of the derived class. And in constructors, if you don't make an explicit call to the constructor of the base class, what will happen? The default constructor of the base class will be called. So whether or not you call person, this will automatically be called. Okay? So constructors and destructors, they have different arrangements.
So virtual functions are always member functions?
Virtual functions are always member functions, that's correct. Do you have any questions?